And our next speaker is Louis Moreau. I hope that I pronounced it well. Louis started his career developing a low-power and GPS-based IoT solution to protect rhinos in an African conservancy. He is now working at Edge Impulse as Senior Developer Relations Engineer. When not hacking development boards or automating repetitive tasks, you can see him riding an electric skateboard in Lille, northern France, or scuba diving in some paradise places. You are lucky. So let's give him a warm welcome.
Thank you, Valeria. Yeah, my name is Louis Moreau. I'm a developer relation engineer with Edge Impulse. I've been with Edge Impulse for about 2 years and a half, and I'm French, as you can hear from my accent. In today's session, I'll speak about, I'll show a programmatic approach to automate your machine learning operation pipelines. The talk session is called pip install Edge Impulse, and it's actually as easy as 3 letters, like just install Edge Impulse Python SDK, and you're good to go. So when we created Edge Impulse about 4 years ago, we had a deep focus on embedded engineers. We wanted to create tools, engineering tools, to help embedded engineers to focus on their daily jobs, but be able to use machine learning tools or techniques in their applications. We noticed after some time, like after 4 years, that among all our users, I see some of you in here, we have more than 80,000 users, and not all of those are embedded engineers. There are also ML practitioners, data scientists, ML engineers, and for those, the platform was not exactly what they are expecting. So we kind of shift a bit our messages and the way we conceive products. We don't change anything on the studio side, but we also wanted to add some new tools to address those ML experts. So we released, I think it was in April this April, a new tool called the Python SDK, along with a new feature which is bring your own model. Before that, you needed to import the data. So your data was the entry point of Edge Impulse. Now we also want you to let you bring your own model and then profile it, and we'll see the different functions. So at the moment, we have 2 main functions with the Python SDK. The first one is the profile function. It lets you select a target. Here it's an architecture, the Cortex M4F at 80 megahertz. And it will give you, based on your model, the RAM information, RAM usage, flash estimation, and latency estimation. So that's actually pretty powerful because now the ML engineers can focus and change a bit the architectures, and they'll get an immediate estimation on whether it will run on the device and at which speed and which resources. So that's the main function, the profiling. And the second function is also the deploy function. The output of this function is either a C++ library, an SLCC component with Simplicity Studio, TensorFlow, Arduino library, basically all the export formats that we officially support with our boards, and all of them are hardware accelerated, so we leverage all the operation for those boards. So how it works? The main entry point now is not the data anymore, it's really the model. So we support TensorFlow, such as like the TF-Lite formats, Keras, the protobuf save model formats, or just ONNX. So you can actually work with every framework you're used to, convert that to ONNX, such as PyTorch or SparkML, and you can profile it. It might not run on an MCU. Obviously, like big models won't run on MCU, but at least you'll know. Or you can adapt your model to make it work and to make it fit on MCUs. So how it works? That's basically all you need to do. It's 3 main functions. So just pip install Edge Impulse. It will install all the dependencies. Then you need to retrieve your API key. So that's probably the only time you'll need to log in Edge Impulse, create a project, and retrieve your API key. Import it as you would do, like import NumPy as NP, so that's import Edge Impulse as EI. Set your API key, and then you can directly profile your model. So here it takes two arguments. First is your model, so on any of the supported formats I just said, and you select a device or an architecture. If you want to have a look at the return, so here it's actually the model that I'm using for the microscope demo at the Edge Impulse table. Feel free to have a look. So here it's a save model float32 format. I'll share after how we do post-training quantization. And I select a device, a Cortex-M, and the output would be like either it's supported on MCU, the memory, and we have two options for the compiler. Either we use the TF-Lite compiler or the Eon compiler, which is something that we developed internally. And we can do a lot of optimization on the RAM and ROM footprints. And then the inference time. And the next function is how to deploy. It takes a couple of parameters. I'm not sure if you see it well. So again, you need to put the path of the model, define the output. What kind of model is it? Here it's a classifier. The deployment, the target type. The name is not great. It's a zip. It actually means the C++ library. It's the first deployment option that we offered, and we called it zip. It's text. And then the output directory, so where you want to put your generated C++ library. So if I want to quantize and deploy, first step I would need to do is to create a set of representative features for the quantization. Here I'm just creating a NumPy array from my test dataset. So it's basically, I've got 36 images of 96 by 96 height and width, and it's a RGB image, so three channels. I'm not going to go through the code. It's basically how to create a NumPy array. And then I label, so I name my generated format, what I'm expecting, so generated C++. I can set my label from here. So here the labels are cotton stem, epidermis onion, housefly legs, unknown, and wood stem. It's actually the labels that you can see on the microscope project. It's basically a classifier. And again, the type. What I need to do now is to call the deploy function. So ei.model.deploy, tell which model I'm using, like an entry model, output, etc. And we'll go through that. We can specify like the deploy model type. And here I specify the int 8, meaning I want to get the quantized version. And if I want to get the quantized version, that's why I need to get the representative features of my data set. And the output of it is a generated C++ library. So those are the two main functions. If you need more, the Python SDK is built on top of our API binding, so Edge Impulse API, which are basically like API calls to our REST API. And we'll add some more functions as we identify some needs from ML practitioners. But those two main functions, we noticed that those were the one who people actually needed. Sorry. I'm not going to go through that, but it's basically how to use the Python, the API binding. And then a couple of interesting things. So on the integration side, we created tutorials on how to use that with SageMaker, Hugging Faces, even like a Keras, basically like a zoo model, I think. And yeah, we support different integration, weight and biases as well. I've been speaking with some people integrating that with the Python SDK. So the main goal is you can keep focus on your pipeline, on the tools you're used to it. Just integrate a couple of functions in your notebooks. We unlock feature engineering and fast and feedback loop. As soon as you make a change in your architecture, you can make sure and you can validate it will be working on your targeted edge device, and empowers model optimization and deployment to any devices, as long as the operation are supported by the microcontroller. And on top of that, we added an example on how to create a pipeline using GitHub Actions. So you can go through each step. So as soon as you make a commit with your new changes, you can just recreate your test pipelines, and the output of it would be like your C++ library, or you can even go further and reintegrate and redeploy the new firmware that you want. So here it's one thing that Jan actually briefly mentioned yesterday. It's the full ELF-ML automation pipeline that we do for. It's basically the same thing that we do for Aura, NoWatch, etc. It's it's a pipeline which is fully automated, where each of the person can focus on their job, and the rest is automated. So you want to automate the data collection part, and you want to optimize your model and make sure it will run on devices. Everything in between is optimized. And the key recap, so we convert like the Python models into efficient C++ library. You can provide profile on-device performances on any trained model. It might not all model might run on MCUs, but at least you know, and we can profile it. You can analyze the impact of your architectural decisions, and we generate optimized C++ libraries for you to deploy on edge devices. Thank you, everyone. Any questions?